I am embarking on my first experiments with geopolymers. So what are geopolymers? In a nutshell, geopolymer is a polymerized inorganic that has repeating chains of silica, alumina, and oxygen. So it's a silicate material that is aluminosilicate material that is polymerized. The technology has been used for a long time, dating back thousands of years, but is regaining popularity as an alternative to ordinary Portland cement. I will be doing some experiments with it to see, well, one, I just want to be able to reproduce it in the first place, and second of all, I want to test it with different composite materials, including natural fibers, as well as things like alkali-resistant fiberglass reinforcement, things like that. I'm looking for a combination of natural ingredients that will yield a good result, but I will also be experimenting with aerated geopolymers, which essentially just means the geopolymer has air bubbles entrained in it, and those air bubbles create a very lightweight and insulative material. So my hope is that I will be able to create composite panels that can be used by themselves as essentially a combination of cladding and exterior insulation, but could also be used as part of an overall wall assembly that would yield results that are comparable to hempcrete and other materials in terms of insulation, but also are load-bearing and ideally replicate all the layers, all of the control layers that are associated with the perfect wall system. So these are my ingredients. I started with this large white bag on the left is kaolin, which is a clay, very common clay material. And the primary ingredients in a geopolymer, it can be made from a lot of different ingredients, but the primary ingredients are metakaolin, which is kaolin that has been treated with heat to 750 degrees, or a little bit higher in my case, for a minimum of 5 hours to drive off all water from the crystal lattice. So I did that over the weekend, and that's what is in these two containers here, metakaolin. This one is totally full. This one has quite a bit in it still. I did so in this bisque vessel, which I see now is actually cracked. So I guess it didn't like being heat treated that way, whatever. This is a solution of sodium hydroxide and sodium silicate, also known as water glass. That's the other main constituent. So these two are mixed and then allowed to sit for a couple of days. This leads to the initial depolymerization of the silica into the solution and makes it available for the actual polymerization. So I will be mixing some of these materials, well, I'll be mixing all of those materials, metakaolin, and this water glass and sodium hydroxide mixture to produce my first batch of geopolymers. Hopefully this goes okay. So my plan is to create some test molds using acrylic. Acrylic is alkali resistant, so that's why I chose that. And I have some materials that I have purchased to add to the mix. So I have, not add to it, but as reinforcement. So I've got this cement fiberboard joint tape. This is alkali resistant for use in mortar. Honestly, I'm not even really sure exactly what it is, but I assume that it is fiberglass. So that's a reinforcement tape. This, which I sure hope is actually galvanized steel. I believe it is. It was next to the galvanized metal mesh that's in the area where all of the stucco material is. So I've got this to experiment with just a reinforcement. I didn't want to have to buy a whole roll of this, and this was only like $6, so I'd probably just take out the mesh and put it in there. I'm also going to experiment with painting the GeoPolymer onto canvas, onto cotton canvas. I want to see how it responds, how the canvas responds to it. I have I have this cool idea that may not work out, but we'll see, that you could drape the canvas to create a flowing sort of organic shape, and then by painting on the GeoPolymer and allowing it to set and providing some kind of support structure beneath it, that you could essentially create a roof out of this material that would mimic the roof of, say, a tent, which could be an interesting construction. I also have some carbon fiber, these little thin rods I got from the hobby store. I'm just going to see what kind of an effect the carbon fiber has in improving flexural rigidity, or I should say flexural strength. I have some steel rebar. This is just 3/8 inch, 12 inches long, and I also have some fiberglass rebar. This is 1/2 inch. This is what was available at Home Depot. I think ideally I'd want to use basalt rebar instead of fiberglass, but I'm going to just see how all of this responds to the GeoPolymer environment. I also am planning on doing some experiments in my dust collector there. There's a lot of sawdust, and I want to try using waste sawdust as an aggregate material and as a fiber or binder, not binder, but as the fiber for the binder. So I'm going to try that as well. So that is the layout of my current set of experiments. Oh, and I suppose I should add also I got some multi-purpose sand. This sand is designed for going in concrete as well. I didn't bother going for the more expensive sand that was sifted to a specific grain size. I didn't need 100 pounds of sand for my purposes, and it only came in 100-pound bags. So I just got this one bag of multi-purpose sand. That should be adequate. I think that's it. All right, so we will get to work, and then I will show you the process and the results. Oh, and then this is obviously where call it my laboratory. This is also where I do my woodworking. So I just got some cheap plastic containers from the dollar store, and a scale, obviously, for weighing out the ingredients. I do have a dust mask that I use because this stuff is obviously fine and powdered and has silica materials in it, so I don't really want to get silicosis. So I have my dust mask, I have gloves, I have safety glasses, and I also got a face shield that I'm going to also wear over my safety glasses just so I don't splash any of the precursor materials. Even though at this point it's diluted sodium hydroxide, it's still sodium hydroxide. And sodium hydroxide, which is also used for cleaning out drains, is very caustic. That's why it's used for clearing out drains. I originally got this sodium hydroxide for making soap. So it's also a few years old. I assume it still is fine. We'll find out if any of this kind of comes together. The sodium silicate I got from the clay or ceramic supply store along with the kaolin. There's no information provided as to what's in it, like in terms of the molar quantities of silica and so forth. So So it's kind of a gamble. I didn't have any data sheets on it, so I don't know what the concentration is of sodium silicate. Hopefully it works out okay. All right, thank you.